Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Okay, Jam. Today we're going to do a podcast for Jam, for you, about Jam.
Oh, nice. So it's about me also, or?
Not about you, about Jam and Jelly.
Oh, okay. Gotcha.
And this topic was requested from our very own Jam Robinson. Not, I think, because it was his name, but I think it, was nice also that it played into it.
Yeah. And I really wish I'd requested it while we were still recording, but it was after we recorded our previous episode. My brain was going, questions were popping up. The little scientist in my brain was thinking, hey, but what about this? And what about that? And so I formally requested this topic, but did not expect it to be so soon. And I didn't even know until right now that we were doing that. So
it was really fun. And I just sometimes will briefly look at topics to see how hard or easy the research will be. And this research was very easy. It presented itself very quick and it was very fun. So that's why I went for it.
Very cool.
Thanks. So sometimes requests will come in that I do a quick search and I think this is going to be hard. And then they maybe don't present themselves as easily because I'm also a graduate student and this is unfortunately a side hobby. So I can't put the time and energy into those harder topics as I wish I could. You know what I mean?
Yeah, totally.
So if you're wondering why your request hasn't been made into a podcast yet, it's very possible that I don't have time to do the research on it at this time. But summer's coming up and I'm going to graduate one day. So hope is still on the horizon for you. I do have a list of them, of the requested episodes. So, well, let's talk first about what jams and jellies and all of that are. So,
okay.
This actually, what I'm about to tell you is just from a Google search. So I don't know if this is official, but I think it's all colloquial. So I don't know if I'm going to find an official source on this first part. So what I learned from Google is that jelly is made with strained fruit juices and it's clear. Jam is made with fruit pieces in it, but it's like mashed up or pureed or chopped up.
Okay.
Preserves have large pieces of fruit.
Okay. So it's kind of a little bit along the lines of what I'd heard colloquially, I guess.
Yes. Well, that's just where I looked this up. I couldn't find any real sources about it.
Mm-hmm.
And then marmalade is made with citrus fruits.
Okay. I never knew what made marmalade, really. I just was like, it's another kind of spread.
Yeah.
You know what I mean? But
yes.
It's citrus.
So, but everything I found indicated that they were all the same chemistry. And we've just made our own little delineations based on how much fruit is in them. So it seems like the chemistry is the same, but the amount of actual fruit pieces is what determines if it's jam, jelly, or preserves. And then if it's citrus fruit versus non-citrus fruit is marmalade category.
Got it. Okay. Interesting.
I think this might be different for different countries. So these are like the American definitions. Because I know sometimes when I'm watching Great British Bake Off, they use gelatin sheets to like set jelly.
Mm-hmm.
And we would call that Jell-O. So I want to also say that this is the American definition of these words from Google, not an outside source. I think it's just what we decide to call them.
Yeah, and I feel like depending on the country, I've felt like they maybe use one of the words for multiple things that we might use different words for. Like jam might be the word they use for lots of kinds of spreads instead of just what we use it for. So that's been one of my thoughts too. And it has maybe even contributed a little to my confusion about it. Like, which is which? But I guess it's not like a real clear like scientific rule about which one's which.
I could not find one. In all of these things, they mostly just said jams or jellies and just kind of left it at that and then mostly used jam from there on out. One of my sources was from the Royal Society of Chemistry, which is not an American source. And so they just said jam the whole time.
Okay, got it.
but I think the chemistry is kind of the same no matter what. So from here on out, we're just going to talk about jam. And it's going to probably apply broadly to all of these categories.
Nice.
If you're a food chemist out there and you know these definitions and you'd like to reach out to me to talk about these definitions, I'd love that. I think that was so fun. So please feel free to do that. So before we get into the topic, I do want you to take some time to think about if you know what jam is or what you think jam is so that you can kind of get in the jam mindset. I mean, you always are because you're jam. But so jam, take a minute, and listeners at home, take a minute to think about what you think the chemistry of jam is.
Okay, so the things that are coming to mind for me are the recent, just last week, maple syrup episode. And that's part of what made me think of the question asking about jam in the first place was just that you talked about how you boil down a lot of maple sap to make maple syrup. And so that made me wonder, is that what's going on with jams and jellies? And then, so I thought maybe that would be it. And that would explain it, because I really don't know how much like fruit juice and fruit stuff it takes to make some jam or jelly. And you talked about how that process creates a lot of different reactions that go on. And so I wondered if that was what was happening. One, you're boiling it down, so there's a lot of like water, I guess you could say, that is removed because of it turns into steam.
Right.
But if it isn't like maple syrup and it's not quite as complicated as like lots of different chemical reactions are happening, if it's just as simple as something that is losing lots of its water as you boil it down, I was thinking maybe if that happens enough that the consistency of it would change and get much more stuck together as the water is going away, and then the molecules maybe have a chance to like form a little bit more like a solid where there's less room for them to move between each other. But that's all that's really come to mind in the quick thinking time.
Okay, well, I'd say that last part is the closest.
Okay.
And I'm also going to say I love hearing your thoughts on it, because studies show that if you think about the answer before you're given the answer, you're more likely to internalize it. So you're taking part in the learning process.
Nice.
So that's great. But I think it's less like maple syrup and more like a mixture between what happens to eggs when we cook them and diapers.
Whoa. Who would have thought?
I know. Isn't that weird?
Yeah, that's crazy.
So for those of you who have not listened to those episodes, go back and check them out. They're two of my favorites. The boiling eggs one, Jam came up with one of the best analogies I think he's ever come up with. So go check that one out. And we had a fun guest on that one, Jason Kress. So definitely check that one out. But that means that there's something in jam that is a polymer.
Oh, man. Dude, that's awesome.
I know. When I was researching this, I almost texted you and said, no spoilers, but I kind of wish I'd become a polymer chemist.
Oh, dang, yeah.
But then I knew it would be a spoiler, so I kept it secret. But man, there's polymers everywhere.
Interesting. I guess it does seem kind of polymer-like in the consistency, but I would not have guessed that just because that is not the only thing that makes it a polymer. But weird, dude.
I know. So for those of you who are newer to the show, there's lots of episodes where I've talked about polymers. But a quick review. A polymer is a large molecule made up of smaller repeating subunits. So a good way to think about this is like a necklace is made up of beads that are repeating different beads. You know, a pearl necklace is a pearl, a pearl, a pearl, a pearl, a pearl, but altogether it's a necklace. So a polymer is like a molecule, a molecule, a molecule, a molecule, a molecule that are all bound together in a chain. And that those little repeating molecules over and over combine to make a polymer. And jam came up with the beautiful way of phrasing it as a molecule that's made up of molecules, which I love. So that's the quick review of a polymer. And there's lots of conversations we've had about polymers if you want to go check them out. But today is kind of going to be a review of some things you've already learned, but kind of in a new application.
Okay.
So if it's not going to be your brand new traditional chemistry lesson that we've had a few times, it's going to be a review, like a review before your exam, a review lesson.
Okay.
We're going to review some things that we've done before. So the thing that is a polymer in fruit is pectin.
Okay.
Pectin is in the cell walls of fruit. It helps give fruit their shape. And when this, I think, is amazing. When fruit gets old and mushy, that's because there's an enzyme that breaks down pectin so it no longer can hold its shape.
Oh, wow.
So pectin gives fruit its shape, but it also gives your jams and jellies its shape.
Okay.
So pectin, like eggs, can form a nice 3-dimensional network. And like diapers, in that network, it has trapped water molecules or fruit juice molecules or whatever.
Uh-huh.
So we talked about how eggs have these long stretched out, their proteins are polymers also, and they'll be long and stretched out. And then because of heat, they're able to stretch out and cross-link and form what's known as an aggregate, which basically means they clump together.
Mm-hmm.
And jam had the beautiful analogy of Christmas lights. If they're all rolled up separately, like proteins normally are, they don't get intertangled and they're easy to organize and move around. But if you just throw them all into like a tub or something, and then you try to pull them out next year, you grab one string and it brings the whole entire mass of Christmas lights with it. Beautiful analogy. So like the proteins in eggs, pectin would be a long stretched out chain. And then I'll talk about why this happens, but it starts to aggregate together. It can begin to form a aggregate or cross-link, bind together, sort of bunch up. And when it does that, in any of the small areas that are left between the molecules, it sort of traps the solvent and absorbs it into the gel. Absorb is not the best word, but it will keep the solvent, the water, the fruit juice, whatever is present already in the mixture, trapped in its aggregate that it's formed. And that part is what reminds me of diapers because they hold the water molecules in their matrix similarly.
Okay. Got it.
So that's where I see jams and jellies being a mixture of egg chemistry and diaper chemistry.
Interesting. Dude, that is crazy.
But that's not to say you should eat diapers. That's not safe. Don't do that. It's just similar on the molecular level. So that's the basics of what jam is and what makes it gel up. But I want to talk about how we get that process going.
Okay, yeah, that's what I'm interested in too. I don't really know much about that either.
First, you have to get the pectin out of the fruit, so to speak.
Okay.
So pectin already exists in the cell walls of the plant. So that's why we heat it and we'll mash it up. It'll sort of bring that out of the walls of the plant so that it can be free to move around. So that's the first thing you have to do to make jam and jelly is get that pectin. And then the second thing you have to do is make it curl up into its aggregate. Curl isn't the best phrase, but I imagine it goes from its natural shape, which is long and stretched out, into sort of bunched up with all the other chords, like the Christmas light analogy. So to do that, you have to change the chemistry of the pectin molecule. And this is the meat of your chemistry lesson today. I mean, all this has been very chemistry heavy, but this is the newest the only new concept we're really going to get for you today. Pectin is in its natural form, unlike proteins, it's already stretched out into longer chains.
Okay.
And the reason it sort of takes that elongated shape is because some of the functional groups, and we've talked about functional groups before, they're just groups of atoms that are classified into sort of subsections because they have similar functions as each other, you know. So anything that has an oxygen and a hydrogen is called an alcohol functional group, and alcohol functional groups behave similarly no matter what molecule they're on, pretty much. So one of the functional groups in pectin is negatively charged. So that means it has an excess of electrons, which are negative.
Mm-hmm.
And just like when you have two magnets and you try to push them together, they're sort of going to repel each other if they're on the same negative side. That happens in pectin. The different negatively charged functional groups are going to repel each other, so pectin's not easily going to fold in on itself.
Oh, interesting.
So that's why it stays in a more elongated shape.
Uh-huh.
And that's why, to make jam and jelly, you don't just need fruit. You oftentimes also need to add acid.
Huh.
So you might see a recipe where there's a little bit of lemon juice mixed into the jam recipe.
Oh.
Or you might be using a fruit that's already acidic.
Mm-hmm.
So like citrus fruits probably don't need an addition of acid because they have a lot of acid already.
Right, right.
So first, we've isolated the pectin. And then we've used acid, which is going to neutralize those negative charges and keep pectin from repelling itself as much as it did before.
Uh-huh, uh-huh.
So that it can start to mix in with itself more, start to form that aggregate, start to form aggregates with other pectin molecules as well.
Yeah.
And then there's one more thing we have to account for, the last step, so to speak.
Uh-huh.
And that's that pectin likes water. It is hydrophilic. It's water loving. It can easily bind to water. And to learn more about hydrophilic and hydrophobic, check out our episodes on soap, the very first episode we ever did, and the episode about COVID-19 with soap. We talk about hydrophilic and hydrophobic a lot.
Mm-hmm.
So pectin loves water. And that water being all around it will keep it from cross-linking and forming the aggregate that it wants to form.
Okay.
So then we mix in something that's going to like water even more. It acts as a bodyguard or an interferer. I don't know what the sports term is for this, but it's going to play blocker or defenseman or something like that, where we're basically trying to keep the water from getting to the pectin.
Okay. I don't know sports
And
any
that
better than
thing
you,
is-
and so I can't help there, but I know what you mean.
Yeah, I feel like I know it somewhere. Is it blocker? I don't know. But there's going to be the enforcer. They're going to be a bodyguard. They're going to keep the water molecules as much as they can away from the pectin.
Uh-huh.
And that thing is sugar.
Okay.
Sugar likes water. Sugar can bind with water even more easily than pectin can.
Uh-huh.
So by adding in the sugar, it gets some of that hydration, some of that water away from the pectin molecules,
Mm-hmm.
so they can more easily find and interact with one another.
Got it.
So those are the three things that are required to form the aggregate. We need to get the pectin out of the fruit.
Mm-hmm.
We need to neutralize or acidify those groups that are going to be repelling each other.
Mm-hmm.
And we need to get some of the water away so that the pectin can find itself and each other and form, I believe it's cross-linking, but I don't know if that has a specific definition or something, but form groups of molecules that come together,
Yeah.
known as an aggregate. And that aggregate is trapping the water and the juice inside the network that forms, just like we talked about with diapers.
Uh-huh.
And that's why we have a delicious, tasty gel that is jam or jelly.
Dude, nice. That's crazy.
I know. Isn't that amazing?
Yeah. I did not expect it to have that many things going on there.
I know. And a lot of that is stuff we've talked about in previous episodes, but it's a brand new application. And I had no idea that pectin was responsible for keeping the shape of the fruit and that an enzyme would break down the pectin. And that's why it got mushy over time. That was amazing. I knew that pectin existed, but I had no idea what it was or the role that it played in the fruit already.
Yeah. Does this explain at all? This might be a totally separate deal about why jam and jelly can last so long. I could guess one part of it is that the process is that you heat it up, and so that might kill, stuff that's in there that makes fruit, ripen and mold and stuff like that. But I've always wondered, like, why can it just last so long? That's like the word.
I have no idea. That's a good question.
The word preserves makes me think of like that was kind of where it came from. It's like, ooh, this fruit is not going to last forever, so let's go ahead and just preserve it.
Oh, 100%. That's what I think too, but I don't know for a fact if that's. I don't know.
Yeah.
I would probably need to do a whole other episode on that.
Interesting. Well, there's still plenty here, so even aside from that.
Yeah.
Dang, dude.
So do you want to take a stab at going back over that, going through the chemistry, and then I'll talk about a few other uses for pectin?
Yes, I'd love to. So I don't have a good analogy for this. I mean, the Christmas lights one that we've kind of already been using around proteins and stuff is helpful, but also this has too many layers to it for like one thing to work, I think.
Yeah, definitely.
So pectin is already just part of the fruit, and it's one of the biggest things that we really need to work for us to make the jam have the shape and consistency that we want, basically. And so
right.
It seems like so many of the things we are about to include in this concoction to make jam is really just to get the pectin to do what we want it to do, right?
100%. We're just bullying that pectin into our will.
So the first thing is just to get it free because it's very integrated into the fruit, part of its cell walls and its overall structure and everything. So we just decided to destroy the fruit and just mash the heck out of it. And that starts to be able to free up the pectin to not be stuck doing a job, I guess you could say. And
right.
And then it wants to kind of repel from other chunks of pectin, I guess, from other strands of pectin because of its its negativity, because it has a lot of electrons. Mm-hmm. So then it's like, okay, how can we get you guys to not be to hate each other so much? If we gave y'all some acid, would you get along? And they're like, oh yeah, we love acid. But it's because acids, if I remember correctly, acids have basically a lack of electrons, but they want electrons, right?
Yes.
Okay. So they come in and they're like, guys, everybody's got too many electrons. Guess who wants them? Me. I want the electrons, please. And so lemon juice or some other acid or something, I guess if the fruit you're mashing itself is acidic and you start to have juice come out of the fruit as you're smashing it, it might help the situation on its own. And then allows that pectin to start interacting with itself and not repel from other pectins, which we want because we want them to start getting all tangled and make these congregates, right?
Mm-hmm. I think they're called aggregates.
Aggregate, dang it. To make aggregates. I was thinking...
Well, congregate's accurate because they do congregate.
Yeah, that's true. I was thinking about conjugation from a few episodes ago and a few times.
Yeah.
I got those mixed up. Okay, aggregate. Sorry about that. And
that's okay. That's part of the learning process.
But they do congregate. But And okay, let me think. Oh yeah, so we want them to start being able to interact together. But one problem is that pectin really likes water, right? And so if we have water in the picture, it might not interact with other pectins as much as we want,
right,
and won't form that nice aggregate that starts to help give the consistency we want and get us toward that more jammy consistency. So we have to put something in there that will basically kind of pull the water away from pectin being able to go to it. Something that
right.
is going to either be attractive to the water or just take over the water or something like that, and get in between them, basically break them up. And like a chaperone at a middle school dance. And so we throw some sugar in there, and that allows that pulls the water away and then lets the pectin do what we've been trying to do the whole time, is cross-link, form an aggregate that starts to be able to be basically like a container polymer thing, like the diaper polymer, that can sort of hold the liquid in it or something. And if it's happening, if it's happening a lot at the microscopic level, it starts to be able to make the consistency of this thing start being more jammy and less just straight fruit juice liquid mash stuff.
Perfect. That was a great explanation. I think you did really well.
Is that everything? I feel like there was so much, but did I miss anything?
That was everything. Yeah, no, that was it. We first got the pectin out. We then acidified the pectin, and you explained acids and what they did even better than I did. So that was great. I'm glad you did that because I forgot to. And then you finished it up finally with when we draw the water away, it forms the aggregate and traps that water and gel inside it. The water and juice inside it to make the gel.
Nice.
Great job. I think this is really fun. I had a great time learning about this. I got so excited when I found out that pectin was a polymer, because you can buy packets of pectin to add to your jams to make it set faster. So that was really exciting.
Interesting.
So I was very excited. Yes, and there's different amounts of pectin in fruits at different stages of ripeness because the enzyme starts to break them down over time. So really the most pectin is in a slightly underripe fruit.
Okay, gotcha.
So you can supplement that pectin. I guess they just figured out a way to isolate it chemically, and they sell it in little packets.
Wow, that's impressive.
And I think jam sugar in other parts of the world has pectin in it as well. Sometimes they sell the sugar and the pectin mixed together.
Interesting.
That's better than buying a packet of pectin, because then you just don't have to measure out how much pectin you need to use. So I wish I lived in a part of the world where they sold jam sugar.
Yeah. Do you know what's interesting too is that this has enough there that makes me realize, like a few other things we've talked about, that this is the kind of chemistry that people have stumbled into doing for so long, because so much of it is able to be figured out on its own, or happens naturally without us having to know about it. So like if you had a pretty acidic fruit, then that part would be taken care of already. And
yes,
just stuff like that
100%.
that made me think about that, like we talked about before.
One resource that I used was a podcast. It's the Chemistry World podcast that is put out by the Royal Society of Chemistry. And they do short snippets, like 6 minutes long, of chemistry information. It's pretty dense. I think someone who already has a background in science would probably appreciate it a little bit more, but anyone could listen to it and learn from it. They just don't break things down quite as much as we do. And they said that the first person to isolate pectin was at 1825 by a French chemist, but we've been making jams for hundreds of years
Yeah.
before they had done that.
Yeah.
So I thought that was really interesting. Another fun fact is that Marie Curie liked to make jam, which absolutely makes sense to me because she was a chemist.
Nice.
I learned about that from an article in the National Geographic, I believe. I thought that was a fun tidbit. It's also used in pharmaceuticals and cosmetics because of the gel that it can make, but it's not dangerous.
Mm-hmm.
It's non-toxic. It could be toxic in the right setting or the right amounts. I don't know. But if we can ingest it safely in jam, then that's a good option for both cosmetics and pharmaceuticals.
Uh-huh.
So it's used in medicines to help coagulate blood if you're having problems with your blood clotting. It can be used as a carrier for drugs for controlled release applications. And in cosmetics, it's used for gels. And it's also used for, I got really excited about this because this is a new thing that I've learned in the process of the podcast, rheology modification. And rheology is the study of fluids and how they moved. And I learned that that existed and that there were people called rheologists in our episode about cornstarch and water. So I was very excited that it's also used it's mostly in foods, but it'll change the consistency or the flow, the fluidity of different foods that food chemists are making. So it's used for rheology modification as well.
Wow. Interesting.
So jam and pectin can be used in all kinds of applications, and there's so much more to it than just sugar and fruit. There's chemistry all up in it. That was very exciting.
Dude, awesome. I've definitely been interested in trying to make some jam at some point. Never have gotten quite motivated enough, but maybe now I will, now that I feel like I know what's going on there. I still wouldn't look up like a recipe or something, but that's pretty awesome.
I followed a recipe from Mary Berry from the Great British Bake Off, and it was very straightforward. I think it would have been easier with jam sugar. I had to guesstimate on the pectin that I used, but I have made raspberry jam and it's gone great and it's really tasty. I've enjoyed it a lot. So it's definitely doable. We can have a masked up jam party with jam.
Dude, yeah.
If you want.
That'd be awesome. I have some peaches that I saved that I never made into jam that I froze that I thought would be kind of cool. But I think sometimes you combine peaches with like another fruit and that can be a cool mixture of jam or whatever. But I've just kept those and I'm like, man, someday I'm going to make those into jam.
Well, thanks for asking that question. It made me very happy. And speaking of happy things, do you have something happy about your week you'd like to share with us?
Yes, I do have a happy thing. Just yesterday, I got my first dose of the COVID-19 vaccine. And
I'm so happy about this.
Dude, yeah, me too. And I signed up a little while ago because I have some reasons that put me in the category of like slightly higher risk, but not like a lot higher. And so I had been on the list for a while and had so many more people ahead of me, which was fine with me. I was like, I'll let our county figure that out and decide whenever I should get it, you know, I'll let them decide that. And then I just got an email earlier this week and I don't know if they had some appointments free up or something like that, but they went ahead and told me to come get it. And so I did yesterday. So I'm very excited and I'm feeling great. So it's been like, here in a couple hours, it'll have been 24 hours and I still feel fine.
Yay.
Haven't felt any symptoms or anything like that sometimes people do have experienced, but I'm just pumped, dude, to like be able to have a little bit of normalcy back in my life once I get the second dose, especially, and feel just a little less worried about this virus, you know?
Yeah. And I'm excited for when we can record in person again.
Dude, yeah, seriously.
That's an exciting thing to look forward to.
Yeah.
And I know that your wife is a frontline worker, so I feel like that's nice to have that line of defense around your baby. So that's good.
Yeah. And she got both of her doses a while ago through her hospital system. But we definitely felt like, just one of us having it doesn't make us feel quite as safe as both of us. So, yeah.
Right. Yay. That's so exciting.
Yeah.
Well, Mine's not quite that exciting. But yesterday was my birthday.
Yes.
So that's exciting. And last year, my birthday was not super fun. I mean, my friends are great and it was awesome, but my mom was sick and we had COVID starting and the world seemed a very scary and unsure place. But I had a really nice day yesterday. They didn't have spring break, which is one of the best parts of my birthday now that I'm an adult, that I get a whole week off. So, I get it. It's for safety. There's a global pandemic, but it still was a really nice day. And my coworkers decorated my office, my little desk, and gave me a plant. And it's so cute. And I got to have a safe social distance meetup with, he already knows this, but with Jam and his wife. And I also got a plant from that. So I'm very excited about my new plants. We can post a picture of them. And had a really nice day. Just got to enjoy some time, safe social distance time with some people that I really care about, and got to eat good cake. And it was just it was a nice, peaceful day.
Dude, awesome. That's great. Very good.
So thanks for my little plant. I'm really excited about it. I'll post pictures of it online. And thanks for this question. I think it was a really fun one. I had a great time researching it. I'm going to have so much more fun making jam now. And thanks to all of you listeners for coming and learning about the chemistry of jam today.
And thank you for teaching us and for doing this topic so quickly. I was not expecting that when I asked you about that. Melissa and I have a lot of ideas for topics of chemistry in everyday life, just like jam and jelly, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and S. Navarro, who reviewed this episode.